This lesson is on math operations for significant figures. We'll be learning how to add, subtract, multiply, and divide significant figures. So just a quick overview. We'll do some addition and subtraction examples, and then after that we'll go over some multiplication and division examples. So for adding and subtracting, the result has the same number of decimal places as the least precise measurement used in the calculation. So this is really important here, least precise measurement. So the best way to really tackle them is to line them up like you did in elementary school. So here we have 145, it's got 3 sig figs. The least precise is in the ones place, and we got 16, and again the least precise, that's 6, is in the ones place. So when we add these two numbers up, it's going to be 161, so the answer will have 3 sig figs, and this is what you will box as your answer. For the second example, it gets a little tricky. The 180 only has 2 sig figs. This 0 is not significant because there's no decimal point. If there was a decimal point, it would be significant, but it's not. The 12 is significant, so it's got 1, 2. So when you add these two numbers up, it's only going to go as far as this really when you line them up and add them. Now how do you, the answer is not going to be 192, you're basically going to round it to just 190. That would be your answer for this problem. It seems kind of weird, but it has to do with that 0 not being significant. Here in the third example, we got 129.0. It's 4 sig figs because it's got a decimal. The second, 23.56, has 4 sig figs. Nothing to worry about zeros there. So when you add them, the least precise measurement is in the 10th place. So I'm going to draw a line. And when I add them, it's going to be 152.56, but I have to cut off at the 10th place. So that 6 is going to round, so it's going to be 152.6 would be my answer for this problem. Again, we don't know what this value is here. You can normally when you add stuff up, you assume that's a 0. When it comes to sig figs, you can assume. Okay, the third example, we are subtracting two values, 0.05, which only has 1 sig fig, and 0.011, which only has 2 sig figs. But when you subtract them, again, the least precise is in the hundredths place. So when we subtract them, you'll get 0.039, you cut it off, and then the answer will be, you just round, 0.04 would be your answer. I think adding and subtracting sig figs is probably one of the most difficult things to do in terms of this whole sig fig section. Okay, let's move on to the next, multiplying and dividing. Multiplying and dividing is a lot easier. And most of the stuff you do in chemistry and physics really has to do with multiplying and dividing. So for multiplying and dividing, the number of significant figures is the result is the number of the least precise measurement used in the calculation. So in my 3 examples here, in the first one I have 23, which has 2 sig figs, and in 201, which has 3. Since my least number is just 2, I'm only going to carry 2 answers, 2 sig figs in my answer. So I have to only use 46. So the answer I would use is 4600. And I would put no decimal point to show that those 2 zeros are not significant. So this would be my answer for this. For this problem, you got 10, which only has 1 sig fig. 522 is 3 sig fig. So in my answer, I can only have 1 sig fig. So when I multiply 10 times 522, I get 5,220. But since I can only have 1 sig fig, I'm just going to write, weirdly, 5,000. And that would be my answer. Again, it depends on the least number of sig figs that's being in operation. So in this case here, 1. Here I have 0.040. This 4 and 0 is significant, so 2 sig figs. Here I have 0.100. These 3 numbers are significant. So in my answer, I'm only going to have 2 sig figs. But when I'm multiplying in your calculator, this comes up. So the correct way to answer this, since you have to have 2 sig figs, is you're actually going to put a 0 there. And that will be the correct answer, 0.040. All right, I hope this helps you out.